Hello everyone and welcome back to our videos. Today we will talk about the fourth type of fire detection system, and it's called cistern donor system. The cistern donor system is another pneumatic continuous loop system that utilizes a gas-filled tube with a titanium wire running through its center as a sensing element. The tube itself is made of stainless steel and is filled with helium gas. The titanium wire, on the other hand, acts as a gas absorption material that contains a quantity of hydrogen. The protection: the wire is either warped with an inert metal tape or inserted in an inert metal tube. One end of the sensor tube is connected to a responder assembly containing a diaphragm switch that provides a warning for both an overheat condition and fire. And the cistern donor is the same principle of Lindbergh system, and we will see the diagram now of the cistern donor system. As you see here in this figure, it's talk about the cistern donor. Here we have the stainless steel tube, and inside the stainless steel we have the core element that made from titanium, and between them we have the helium gas. Here we have our circuit, the power supply and the integrity switch, and we have the alarm switch, and we will understand the function of the integrity switch at the last of this video. As we see here, when the sensing element is exposed to a fire, the temperature will rise for indicate there is a firing. Here the helium gas will expand and will make the alarm switch to contact. When the alarm switch contact, the fire warning will be presented on the cockpit. As we see here, when there is a malfunction, our sensing element and the helium gas will release out from the system. The integrity switch will release out. When it released, the fault warning will appear on our system and make alarming on the cockpit. The last type of fire detection system is the flame detectors. Another type of fire detection system that is used on an aircraft is a flame detector system. Most flame detectors consist of photoelectric sensor that measures the amount of visible light or infrared radiation in an enclosed area. The sensor is placed so it can see the surrounding area, and anytime there is an increase in the amount of light that strikes the seal, an electrical current is produced. Once enough current is produced and channeled through an amplifier, a fire warning light and bell are activated. We will talk on the smoke detection more about the electric sensor, and you will understand the photoelectric seal and photoelectric sensor that will change the light that come to electrical signals. Smoke and toxic gas detection system. The smoke detection system of the aircraft monitors certain area of the aircraft for the presence of smoke. which can be an indication of an impending fire condition. These may include, but are not limited to, cargo and baggage compartments and the lavatories of transport category aircraft. A smoke detection system is used where the type of fire anticipated is expected to generate a substantial amount of smoke before temperature changes are sufficient to actuate an overheat detection system. Also, the presence of carbon monoxide gas or nitrous oxide are dangerous to flight crews and passengers and may be indicate a fire condition. Detection of the presence of either or both of these gases could be earliest warning of a dangerous situation. Smoke detectors. To be reliable, smoke detectors must be maintained so that smoke in compartment will be indicated as soon as it begins to accumulate. In order for the detector to operate properly, smoke detector louvers, vents, and ducts must not be obstructed. Smoke detection instruments are classified by method of detection, and in some cases, an aircraft will have different types of detectors installed in various locations. The smoke detectors have three types. The first type, light refraction type. This type of detector consists of a photoelectric cell, a beacon lamp, and a light trap, all mounted on labyrinth, and we will say that on the figure 16-17. Air symbols are drawn through the detector unit, usually by a small circulating fan. When smoke particles are present, they refract light into photoelectric cell. An accumulation of 10% smoke in the air causes the photoelectric for illuminate. As we see here in this figure, we have the component of our light type. Here we have the project lamp or source of light, or as they mentioned in the book, beacon lamp. And here we have the photoelectric cell. Also we have the light louvers, and we have the OBQ barrier. The photoelectric cell is a device which produces the electricity when it exposed to light. The greater the level of light, the greater the electrical current it will produce. The photoelectric cell is sitting in darkness. It's shielded from the light source's output by an OBQ barrier. Outside light is prevented from entering by the light louvers, but air can flow through the unit. If smoke enters the unit, it will scatter the light. This will cause some light to be seen by the photoelectric cell. The cell now will produce an output which will trigger an alarm. How to make test for this detector? Here we have the test lamp. This test lamp will illuminate and will give a light to the photoelectric cell. When this light arrives to the photoelectric cell, the photoelectric cell will generating and alarming on the cockpit. How? By producing an electrical signals, and it will send this electrical signals to the warning and make the alarming that we have a fire. How that's come? When we push the test switch on the cockpit, the test lamp will illuminate lights to the photoelectric cell as we talked. The photoelectric cell will change this light into electrical current and will illuminate the smoke detection on the cockpit.